Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your same module, that is the procedural programming module. And then in the last class we have started with chapter number 19, that is how to interact with the hardware, that is interaction with the hardware. In the today's class I'm going to continue with the same topic, same chapter, that is how to interact with the hardware, that is interaction with the hardware. So now let's start with the previous session. And yeah, one more thing, we have also finished chapter number 18. In the last class we have covered some topics of the chapter number 18, that is how to use the WM create function message, how to use the WM timer message, how to use the on create function, how to use the on timer function. So we have finished with the summary, each and everything of the chapter number 18. Now let's start with the previous session, that is what we have covered only for the chapter number 19, not for chapter number 18. So let's start with the basics of the chapter number 19. We have started with chapter number 19, that is interaction with the hardware, that is how to interact with the hardware. There are multiple topics that is available. One is hardware interaction, one is the hardware interaction DOS perspective, one is for the Windows perspective, one is the communication with the storage devices, that is the read sector function, then how to access the storage devices, communication with the keyboard, dynamic linking, window hooks, caps lock permanently, that is how to use the caps lock permanently within it. So we have started with the introduction of the how to interact with the hardware, that is the interaction with the hardware. So this first paragraph says there are two types of Windows programmings, or there are two types of Windows programmer that is available. Those who are happy in knowing the things the way they are under Windows, and those who wish to know why the things are the way they are. That is, there are two types of person that is available. One simply accept that these are the things, we are acceptable with these things. One is the person that have a curiosity to know why this happens, what is the logic behind this. So this chapter is based on the second type of programmer who have a curiosity to find out what is the things, what is the logic behind it. That is going into the deep of the matter. That is the second category of the programmer, and this chapter is based only for those programmer who want a deep knowledge about the C programming, who want a deep knowledge about the hardware, how user hardware with the user interact with the hardware, how the hardware devices interact with the another one. So first topic that we have discussed is the what is hardware interaction. So this is the first topic, that is the hardware interaction. This says primarily interaction with the hardware suggests interaction with the peripheral devices. So in simple terms, whenever someone asks from you what is the hardware interaction, in simple terms, whenever we interact with the peripheral devices, we interact with the input output devices, that is known as the hardware interaction. However, its reach is not limited to interaction with peripheral. That is, its boundary is not tied with the peripheral, but it is going much beyond to the peripheral. We have discussed that how to communicate with the chips. That is, more currently or more correctly, interaction with the hardware would mean interaction with any chip other than the microprocessor. During this interaction, one or more following activities must be performed. So whenever there is a hardware interaction, the following activities may be performed. What are the activities that is performed? That is reacting to events that occur because of the user interaction with the hardware. That is, we can react, or whenever there is an interaction, so we can react to the messages, we can react in the following activities of one or the more following activities that must be performed. So reacting to events that occur because of the user interaction with the hardware. Then next one is reacting to events that do not need explicit user interaction, that does not need the explicit conversion, explicit user interaction. For example, on taking off a timer, our program may want to do something. Then third category is what are the activities that must be performed during interaction, that is explicit communication from a program without the occurrence of a event. That is, there is explicit communication that is available from a program that is without the occurrence of an event. For example, a program may want the send or may want to send a character to the printer. That is the example that is done by the hardware interaction. Now, let us now see how this interaction is done. That is, we have to understand the concept. There is an interaction, there is a communication that goes under the interaction. So let us now see how this can be achieved or how this interaction is done under the different platforms. So first topic is, that is a today's topic also. So this is what we have covered about chapter number 19 in the last class, along with the chapter number 18 finished. So let's move to the next approach, next topic, that is hardware interaction, that is based on the DOS perspective. That is the DOS perspective, that is the disk operating system perspective. This says under DOS, whenever an external event, that is like pressing a key or ticking off a timer, occurs, a signal known as the hardware interrupt is generated. So whenever any external event occurs, or when any external things can occur, like what are the external things, like pressing a key, ticking off a timer. So whenever there is any external thing that occurs, so there is a timer or there is a interrupt that occurs, that is known as the hardware interrupt. So what is question arises, what is the hardware interrupt? So whenever there is an external event that occurs, that is or that causes the hardware interrupt, or that generates the hardware interrupt. For different events there are different interrupts. That is, there are different interrupts for the different event. As a reaction to the occurrence of an interrupt, a table known as the IVT is looked up. That is, how to use the IVT, or a new table is used that is known as the IVT, that is the interrupt vector table. Then this IVT is present also on the memory. It is populated with the address of different BIOS routine. That is, it is feeding up, or it is feed up with the different BIOS routine that is available, that is basic input output system routines that is available during the booting. Depending upon which interrupt has occurred, the Microsoft or microprocessor picks up the address of the appropriate BIOS routine. So it depends on the different interrupts, or it depends on the interrupt to interrupt that occurs, that is available under the microprocessors. And then once the control reaches the BIOS routine, the code in the BIOS routine interact with the hardware. That is how it will interact with the hardware. Since these routines serve the interrupt, they are often known as, or they are generally known as, the interrupt service routines. That is, these routines serve the interrupt, that they are often known as the interrupt service routine, that is simply the ISR. So ISR is a technique that is available, that is the interrupt service routine. This is the diagrammatical representation of the ISR, that is the internet service routine that is available. There are two, this example shows that there are two keys, or there are two input and output devices. What are the two input and output devices? That is the keyboard and the mouse. Then there is a key hit, mouse hit, that generates an interrupt. So if the keyboard is pressed and the mouse is pressed, then hits a key hit or the mouse hit or the mouse click, that generates an interrupt. Then it goes to the microprocessor that looks up in the IVT table, that is the internet vector table. Then address of this one is also occurred in the IVT, also placed in the IVT. Then suitable ISR is called, either ISR 1 or ISR 2. If you want that instead of using the default ISR, our routine gets called, it is necessary to store the address of this routine in IVT. So if my requirement is that I have to use this one, I have to use the hardware interrupt, that is also possible in case of hardware interrupt that occurs, or we have to send the address of the IVT that is picked up, and control is transferred to the routine. Explicit communication with the hardware can be done in following 4 ways. So what are the 4 ways in which the explicit communication takes place. That is, explicit means external communication takes place. So these are the four methods, these are the four techniques, or these are the four ways in which we can achieve the interaction with the hardware. That is the external interaction. So first of all, there is a C program. This is a C program that is available. Then there is a BIOS function. This is the BIOS function. This is the DOS function. This is the library function. There are three types of functions. That is, one is BIOS, one is DOS, one is library functions. There is a direct interaction with the hardware. So either it can be achieved using the BIOS function. Either it can be achieved, that is, the interaction with the hardware is achieved using the BIOS function, using the DOS functions, using the library functions, or there is a direct interaction among the hardware and the program. So let us now discuss the pros and the cons of using these different methods to interact with the hardware. That is, what are the pros, what are the advantages, and what are the disadvantages of using these different methods that is available to interact with the hardware. Now let's start with the first one. That is, the first one is calling the DOS function. That is this one. This is to interact with the hardware, a program can call DOS function. That is, interaction with the hardware. For interaction with the hardware, that needs a function that is known as the DOS functions, or they need a program that is known as the DOS functions. Right. These functions can either directly interact with the hardware, or they may call the BIOS functions. That is, these are the functions that is available. Either they can directly interact with the hardware, or they may call the BIOS function, that is the basic input-output functions, which in turn interact with the hardware. So either there is a direct interaction between the hardware and the function, or either there is a mediator that is known as the BIOS function that acts as a mediator between the function and the hardware. As a result, the programmer is not required to know all the hardware details to be able to interact with it. However, since DOS functions do not have names, they have to be called through the mechanism of interrupt. That is, since DOS functions do not have any names, do not have any values, they have to be called using the or through the mechanism of interrupt. This is difficult since the programmer has to remember interrupt service number for calling the different DOS functions. So this is difficult. Why is it difficult to remember the mechanism of interrupt? Because the programmer has to remember interrupt service number for calling different DOS functions. Moreover, communication with these functions has to be done using the CPU register. So with the use of CPU register, the interaction is done. So this whole paragraph explain you that how to use the DOS function within the BIOS functions. So moreover, communication with these functions has to be done with the using CPU register. This leads to lot of difficulties since different functions use different register for communication. That is, there are so many difficulties. Why? What are the difficulties? Because there are different functions that is available for different registers that is used for the communication. So one has to know details of different CPU registers, how to use them, which one to use them, and when. So for interaction with the hardware with the help of the CPU registers, one must have a knowledge of each and everything. Like what are the types of CPU registers? Like MAR, that is memory address register, MBR, that is a memory buffer register, PC, that is a program counter, AC, that is the accumulator, IR, that is the instruction register, and there is a DC, that is a device context. So what are the different types of registers available, how to use them, that is how to tackle the registers, how to use the registers, and which one is best one, or which one is the best register that is used, that is which one to use and when, and etc. These are the few terms, and there are so many terms available, like what is a register, what is the size of the register, how many bits are available in the register. So that is every user have a knowledge of the this one, have a knowledge of the CPU registers whenever there is a calling to the DOS functions. The next part is that is how to interact with the hardware by calling with the BIOS function, that is by calling the BIOS function. In this case, it becomes a mediator between the function and the hardware. So this says those functions can carry out jobs like console input output, file input output, printing, etc. That is, those functions can carry out the jobs, can carry out the task like console input output, that is single input output, file input output, printing, etc. For other operations like generating graphics, carrying out serial communication, etc., the program has to call another set of functions known as the ROM BIOS functions. So for the other operation, that is, for example, generating the graphics, carrying out the serial communication, the program has to call another set of functions that is known as the ROM BIOS functions. That is for generating the graphics for the serial communication. Note that there are some functions in ROM BIOS that do the same jobs as equivalent of the DOS function. That is, there are some function that is available in the ROM BIOS function. There are some variable that is defined that is equal to the DOS functions. BIOS functions suffer from the same difficulty as the DOS function. That is, knowledge of the CPU register is the most difficulty. Hence, they have to be known as using the interrupt and involve heavy usage of the register. The same difficulty which happened in the DOS programming with the help of the DOS, whenever we use the DOS programming, so the same difficulty is captured by this one, that is by using the interrupt and the use of the heavy use of the register. That is a heavy usage of the registers. Now, the next part is how to interact with the hardware by calling the library functions. That is also the next part, that is by calling the library function that is available. So this says when we call library functions, which in turn can call DOS BIOS function. That is, there is a mediator of the, or this is the mediator, that is a library function that is available. That is a function which in turn then call the DOS BIOS function to carry out the interaction with the hardware. That is, the library functions are used for the interaction with the hardware. Good examples of these functions are printf, scanf, getch for interaction with console, fsread, fswrite for interaction with disk, bioscom for interaction with serial port. So these are the various functions that is available, various library functions that is available whenever I want to interact with the hardware. And these are the library functions that is available, or that can call the both the function, that is either DOS, that is either the BIOS functions. Good example of these functions are, that is, what are the good examples? Like printf, scanf, getch. So these are the good examples of this function, that is the DOS BIOS functions. For interaction with serial port, etc., that is, printf is used with the interaction with the console, fsread and fwrite is used for the interaction with disk, bioscom is used for the interaction with serial port. But the library does not have a parallel function for every DOS BIOS function. Hence, some point of time one has to learn how to call DOS BIOS function, that is, how to use the DOS BIOS function. Now, directly interacting with the hardware. So we have finished with the 3 points. That is, we have finished with the BIOS function, that is how to interact with the, or how C program interact with the hardware with the help of the BIOS function, how C program interact with the hardware with the use of the DOS functions, how C program interact with the hardware with the use of the library functions, and how C program interact with the hardware with the use of the direct interaction with the direct communication. Now, next is directly interacting with the hardware, that is the last part. This says at times the programs are needed to directly interact with the hardware. That is, there are some conditions that programs have to be directly interact with the hardware that is available. This has to be done because either there are no library functions or the BIOS functions do this, or if their reach is limited. That is, there may be any condition, there may be any scenario whenever there is a requirement for directly interacting with the hardware. Either the library functions are not available, either BIOS function, DOS function are not able to do this, or either uh, the reach is unlimited. That is, the reach is limited, not unlimited, limited. That we cannot access those library functions from the function from the C language or from the hardware. For example, while writing good video games, one is required to watch the status of the multiple keys simultaneously. That is, while writing or while using the good video games, that is, whenever we use the good video games, one is required to watch the status of the multiple keys simultaneously. The library functions as well as the DOS BIOS functions are unable to do this. That is, they are unable to do this one. At such times, we have to interact with the keyboard controller chip directly. That is, this is the best example. So whenever we use the video games, or whenever we display the video games, that is available, that is able to get the or watch the status of the multiple keys simultaneously. The library functions as well as the DOS BIOS functions are unable to do this. At such times, we have to interact with the keyboard controller chip directly. However, direct interaction with the hardware is difficult because one has to good knowledge of the technical details of the chip. That is, whenever we want that this will be required, so we have a knowledge of this one. We have a knowledge of this one. That is the we have knowledge of the clip controller. We have a knowledge of the good knowledge of the technical details of the chip that is able to do so. Moreover, not every technical detail about the hardware, how the hardware forms a particular manufacturer works, is well documented. That is, we have one must have a good technical knowledge, a good technical detail about the hardware. So this is the hardware interaction, that is how to interact with the hardware, that is based on the DOS technique, that is based on the DOS values, that is based on the DOS perspective. Now, in this we have studied the four methods for interacting with the C program interact with the hardware. One is by directly interacting with the hardware, calling the library functions, calling the DOS functions, calling the BIOS functions. Next is hardware interaction, that is on the Windows perspective. One we have discussed, that is a hardware interaction that is on the basis of the DOS perspective. This is the hardware interaction on the basis of the Windows perspective. That is the hardware interaction Windows perspective. This is like DOS under Windows to a hardware interrupt get generated whenever an external event occurs. So whenever we use the DOS, in the same way, whenever we use the Windows, a hardware interrupt get generated. A hardware interrupt get executed, generated whenever an external event occurs. So if there is any external event, so there is a new hardware interrupt that is occurred in case of the Windows perspective also, like in the same case of the DOS perspective. As a reaction to this signals, reaction to this signal, or as a result, a table known as the IDT. In that there is an interrupt vector table. In this there is an interrupt descriptor table. That is the IDT is looked up, and a corresponding routine for the interrupt get called. It gets used. Unlike DOS, the IDT contains the address of the various kernel routines, that is instead of BIOS routines. That is, it is using the kernel routines that is available over here. So IDT is looked up and the corresponding routine for the interrupt get called. So there is a IDT, that is the interrupt descriptor table, that is available whenever we use the hardware interaction within the Windows perspective. Unlike DOS, the IDT contains the address of various kernel routines. That is, in IVT there is no addresses of the various kernel routines, but in the IDT that contains the address of various kernel routines instead of the BIOS routine. These routines are a part of the Windows operating system itself. So what are the kernel routine? That is a part of the Windows operating system itself, that is available under the Windows. When the kernel routine is called, it in turn calls the ISR that is present in the appropriate device driver. So whenever the kernel routine is called, whenever there is a requirement of the kernel routine, that is in turn calls the ISR that is present in the appropriate device driver. This ISR interact with the hardware, that is the same scenarios. In that there is IVT, there is a ISR. In the same way, in this there is a IDT, that is a interrupt descriptor table, and there is a ISR, that is a interrupt service routine that is available for the choosing the appropriate device driver. This ISR interact with the hardware, that is this ISR must interact with the hardware. Now, two question arises, or that may occur to you. That is, two question arises from you. Why the kernel routine does not interact with the hardware directly? What is the reason why the kernel routine does not interact with the hardware directly? Why the ISR of the device driver not registered directly in the IDT? That is why the kernel, or why the kernel routine does not, or why there is no direct communication among the kernel and the hardware, and why the ISR is not registered directly with the IDT. That is, there is no direct communication between the ISR and the IDT. These are the two questions that arises from the last paragraph. Right. So the answer to this question is, first of all, let's take the answer to the first question. That is why kernel routine does not interact with the hardware directly. This says every piece of hardware works differently than the other. That is, every piece that is available under hardware that works differently from the other, or than the other. A new pieces of the hardware comes into existence. New code has to be written to be able to interact with them. So every piece of hardware works differently than the other. That is, every part of the hardware is different from the other. As new pieces have come up, that is, whenever we add new pieces to the hardware, that is, comes into existence, new code has to be written into, or to be able to interact with them. That is, new codes are available in this to be used for the interaction with the hardware. If this code is written in the kernel, then the kernel would have to be rewritten and recompiled every time. That is, every time he has to, or it has to, or kernel has to recompile the code, rewrite the code every time a new hardware has come into existence. This is practically impossible. So it is very practically impossible. That is how hardware interact with the, or how there is an existence of the hardware that is that has to be interact with the new code that is available. Hence, the new code to interact with the device is written in a separate program that is known as the device driver. Therefore, the new code that is available, available to interact with the device, that is written in a separate code, a separate program that is known as the device driver. With every new piece of hardware, a new device driver is provided. That is, whenever there is whenever there is a new piece of hardware, a new device driver is provided. This device driver is an extension of the operating system itself. That is, for communication, or for communication with the hardware, there is no direct communication, but there is a mediator that is available, that is known as the device driver, that is available, and that is an extension, or that is a part of the operating system itself. Now let us answer the second question. What is the second question? Why the ISR is not registered directly in the IDT? That is, why there is no direct communication among the IDT and the ISR. The answer of this question, this answer says, out of the several component of Windows operating system, a component known as the kernel is tightly integrated with the processor architecture. That is, it is directly interact with the process architecture. Out of the several component, a component known as a kernel that is directly interact with the processor architecture. If the processor architecture changes, then the kernel is bound to change. That is, there is a direct communication, or there is a direct connection among the kernel and the processor architecture. So if the processor architecture changes, or there is a change in the processor architecture, then the kernel is bound to change. One of the goals of Windows NT family was to keep the other component of the operating system. That is one of the goals that is available for the Windows NT family was to keep the other components of the operating system and the device drivers portable across different microprocessor architecture. That is, these are the goals available about the Windows NT family, that is able to keep the other components of the device driver that is portable across different microprocessor architecture. All processor architecture may not use IDT for the registration and lookup mechanism. That is, all the processor architecture may not use the IDT, that is the interrupt device table that is available. So head registration of the device driver, that is ISR in IDT, being allowed. So whenever the registration of the device driver that is available with the ISR in the IDT that is been allowed, then the mechanism would fail on the processor who do not use IDT, therefore compromising the portability of the device driver. So in simple terms, there are some compromises that is available whenever the IDT interact with the ISR. So we are not able to interact with the ISR directly with the IDT, but there are some mediator that is available that makes the communication easily and effectively. Now, this figure 19.3 understands the interrupt handling mechanism under Windows. That is what we have discussed under the DOS. In the same way, there is a diagrammatical representation how to interact with the hardware with the use of the Windows perspective. So again, there are two parts. One is a hit or key hit, one is a mouse click. That is hitting the key with the help of the keyboard and clicking the mouse or with the help of the mouse, right? In the same way that we have discussed in the DOS perspective. This is a microprocessor. So first of all, key hit or the mouse click that generates an interrupt. So whenever we click with the keyboard, or whenever we uses the mouse, there is a interrupt that occurs that is provided by either the mouse, either by the keyboard. And whenever there is a click, that goes to the microprocessor, or that is going to the microprocessor. Then microprocessor looks up into the IDT, or looks up into the ISR, or looks up into the IDT that contains the addresses of the ISR. So the left side arrow, that is this arrow, indicates that the Microsoft looks for the IDT that contains, or this is the IDT that contains two addresses. One is the address of the ISR1 and one is the address of the ISR2. After address of the ISR2, there is a suitable kernel routine that is called, that is available under this, that is the kernel routine 1 and the kernel routine 2. So these are the two routines that is available, that is the kernel routine 1 and the kernel routine 2. So whenever there is a kernel routine, there is a suitable ISR is called, suitable internet service provider is used, internet interrupt service provider or service relay is used. In the same way, suitable ISR is called. There is a ISR, there is a device driver. So these are the terms that is available, or this is a figure that shows how to deal with the keyboard, how to deal with the microprocessor, how microprocessor looks up into the IDT, how IDT is linked with the kernel, how kernel is linked with the ISR. So there is a communication between the keyboard and the ISR, but this is the whole process that goes under the with this one. Right. So this is the suitable ISR that is called, that is the ISR, and this is also the ISR. This is the device driver. This is the suitable ISR that is called. So this is the diagram that shows how it works. Right. So let's now stop theory over here only. So now let's take a break first of all and then move to the practical approach, that is continuation of the array that we have discussed in the last class about the string, about the array. So first of all, let's take the 5 to 10 minutes break and then come back starting with the array topic, practical approach of the array. So thanks a lot. Now let's start with the practical approach, that is the continuation of the arrays, that is what we have discussed about the arrays in the last class, that is reversing the string. So come back from the break and starting with the practical approach. In the last class we have discussed about the program, that is write a program to print the string in a reverse order, that is printing the string in a reverse order, that is the main concern. That is how to print in the string in a reverse order. Suppose we have entered the input as HELLO, then the output is OLLEH, that is a reverse of the string. Now my next program is on the basis of the array itself, that is a program to detect the occurrence of a character in a given string, that is to find out about a given string that is available in the string. So my program is write a program to detect the occurrence of a character in a given string. So let's start with the program, that is hash include stdio.h, then hash include conio.h. These are the two header files. Then there is a void main function, then there is a curly braces for the void main. Now I have declared one variable, that is char s as a array as a 5, for example, or 5, or we have to give one more one, that is a 10, right? So we have declared one array, that is s, that is contain 10 value, that is from 0 to 9. Now in the next line there is a variable, that is I, then c equals to 0. There are two more variable, that is declare, and then one more simple variable, that is a character, not an array, that is a char f. Now uses the same concept, that is a clr scr for clearing the screen. Now there is a puts function for entering a string, that is enter the string. Now we have to gets the function, that is the gets, then there is a s, that is the getting the or scanning the function, then there is a puts, that means simply print the values in the next line, that is enter a character to find out. Now there is a gets, then no, there is no requirement for the gets. Why? Because we have to pick up the function or pick up the values and store in the output. So we have to use one variable that we have already defined, that is a f, that contains the character, and we use the function, that is a getChar function. Now this is the function calling. Now using the for loop, that is for I equals to 0, I is less than equals to 10, I plus plus. This is the requirement. Now there is a curly braces start. Now start the condition, that is if si is equals to f, that is if it is a condition, then there is a c plus plus. Now if it is equals to f, that is stored in the getChar, then c plus plus, that is every time it will be incremented. Now, simply print up the statement uses the printf for printout purpose, for printing purpose, the character that is a percentage %c for displaying the character also in the on the screen, that is a percentage %s occurs percentage %m times d times, that is also this one, then there is a f because of character, then s because of string, then c because of C++. Then simply uses the getch for taking the output. Now closes this function. If I compile this function, if I execute this function, enter the string. Suppose we have entered the string as a programming or programmer, right? So enter the character to find out, it will ask. So suppose we have given programmer. In this there are multiple times the R will used. Enter the character to find out. Suppose we have entered the character as a 3 R. So this says R will print in the 3 times because there is a PR, then GR, then at the end R. So this will occurs or this will print in the 3 times. Now if I again compile this code, enter the string. Suppose for example the same string, that is a programmer. Now I have to find out how many times the M will be printed. The M, this will occurs or this will print in the 2 times. So this is the way how we are able to detect the character within the string. So this is the write a program to detect the occurrence of a character, that is how many times a character will occur in a given string. So there are again the same 2 header files that is used, that is the hash include stdir.h and the hash includes conio.h. So these are the 2 header files, and then there is a void main function, that is a main function, that is a starting function. Then there is a char s10, that is a char, that is of character, that has a array, that is a s, and then there is a 10. Then this is means this array will declare, and the array name is s, and the values that contain in this is the from 0 to 9. Then there are 2 integer type variable declared, that is the I equals to 0 int I, and the c equals to 0, that is the I and the c. Then there is a char, or the f is declared of character type, that is a char f. Then there is a clear screen, that is a clr scr function. Then simply use the puts like a printf, that is a puts enter the string, that is enter the string. This line will be printed as it is. Then there is a gets. So one is puts, one is gets. So one is the puts, that is the puts enter the string. Then there is a gets for getting the or for scanning into the memory, and uses the variable that is the s. That is after puts it uses the variable that is the s. So we have to scan the into the variable that is the s. S is an array. Now printf or puts the another string, that is enter the character to find out, that is then C++, that is every time it will be incremented. If it is equals to F, that is the character that I want to find out, it is equals to SI, that is equals to the S0, then there is a C++. Then printf the character, that is the character that is given by the F, that is given in the C, that is percentage C, in a string that is given by the S, that is for example M in a programmer occurs how many times, that is a percentage D, and the variable that is used is F. This is F, this is S, this is S, this is C, that is of integer type, that is we have declared with the 0. This is C++. Then get CH. So this is the way how it will be incremented. So first of all it is at the 0, then check for the 1, then check for the 2, then check for the 3, then check for 4, 5, 6 and so on till 9, because it contains or it starts with 0 and ending with the 9. Right. So this is the program that shows the occurrence of a character in a given string. I want to save this file. That is st occurrence. Right. So this is the program. This program is clear to each and everyone? Hello. Hello. Yeah, this program is clear to you? Hello. Yeah, this program is clear to each and everyone. Now let's see another program of the array that is simply used to print the names of the name of the weekdays or name of the days of a week. For example, Monday, Tuesday, Wednesday with the help of the array. So let's start. So what is a program? Write a program to display names of days of a week. Now let's start. That is hash include stdio.h, then hash include conio.h, then there is a void main, then there is a curly braces, right, then there is a int day, that is 7, then one more variable declare, that is I, then clr scr, that is I, then uses the printf, then enter the printf, that is enter the number from or between 1 to 7, right, then simply scanf, uses scanf for scanning into the memory, that is day I, then simply uses the for loop for printing. It starts with the 0, that is we have declared with the I, it's right. Okay, so it starts with the I, then I is less than equals to 6 because there are total 7 days and we have declared 7, then I plus plus, then uses this one, that is starting of this one, or because there are so many braces, so I can skip off this one, that is switch, then there is a array that is declared, that is the array of I, right, then uses this one, that is the case 1, yes, yes, Pardon? Okay. 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 No issues. Uh, you can change it to the puts and the gets also. No issues. Okay. And for safer side, you have to include the header file one more, that is hash include string.h. Nothing more. Right. So what is a case 1? That is a printf. That is the first day is Monday. More precise, that is the first is Monday. Then there is a break. Then there is a case 2, that is printf. Second day is Tuesday. Then again there is a break. In the same way, case 3, that is printf. Third day is Wednesday. Then break, that is case 4. Then simply printf, that is /n, that is the fourth day is Thursday. Then simply uses break, case 5. That is fifth day is Friday. Then again there is a break. Then there is a case 6, that is also uses printf. That is seventh day. Sixth day is Saturday. Then again there is a break. So Monday, Tuesday, Wednesday, Thursday, Saturday, this one. Right. Again there is a break, that is case 7. Simply uses the printf. Sixth day, and then the seventh day Hello, 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 hello. Yeah, are you able to hear me? Okay, so this is a program that shows how to use the uh, days of the week, how to display the days of the week. Now let's open this program. What is the program that is for weekdays? Weekday, yeah. So there are header files that is used, that is a conio.h, stdio.h, string.h. So this puts function is available in the string.h. Now there is a variable declaration, that is int day 7 I, that is two variables are declared. One is of array type, that is of integer, that is the day variable that contains 7 values, and one is a I variable. Then there is a CLR SCR for clearing the screen. Then there is a puts. So instead of using the printf, I have used the puts. No issues. There is no difference between the puts and the printf. The both work for printing on the screen. That is enter the number between 1 to 7. That is enter the number that lies between 1 to 7, because there are total 7 days of a week. We can simply use enter the number, not specifying the range, that is from 1 to 7. Then uses the scanf, that is scanf percentage C D ampersand day I, that is it is used for scanning the in the memory, that is ampersand day I. That is for the scanf purpose, that is for storing into the memory, that is day I. It starts with a 0, then 1, then 2, then 3. Then uses the for loop, that is for I equals to 0, I is less than equals to 6, I plus plus. So it starts with a 0, it end with the 6, because there are total 7 days. So it starts with 0, end with the 6, then there is a I plus plus. So then uses the switch case, that is switch day I. So first of all it is switch day 0, that is if it is 0, then there are multiple cases. That is case 1 is printf that the first day is Monday, then case 2 second day is Tuesday, then case 3 third day is Wednesday, 4th day is Thursday, Friday, Saturday, and at last Sunday. But if it is not the case of the all the 7 cases, then if the user enter the value 8 for example, then what is the default value? That is the invalid day. Now if I compile this code, that gives no error. If I execute this code, enter the number between 1 to 7, I enter 8, that is invalid day, invalid day, invalid day, invalid day. That is available multiple times, that is a invalid day. Right. In the same way, if I again compile this code and I have entered the 1, this is the invalid day, invalid day, invalid day. There is some problem in this one, that is there is some error in this program, because 1 is not a invalid day, but 1 is a valid day. So I think there is some problem. Let's see, or let's check. It starts with the void main. Yeah, it starts with day 7, then I, then printf. If I use printf over here, let's example. Right. Now if I again compile this code, this is again the invalid day, invalid day, invalid day. Now if I not using this one, and if I give the enter, invalid day, invalid day, invalid day. So there is some problem in this. Let me check. This is the for loop, this is the switch case, then there is a case 1, simply printf, break, again there is a break, 4, 5, 6, 7 cases. Okay, I have to enter the number. Now if I compile, that is 1, 2, 3, 4. This is also invalid day, invalid day, invalid day. This is gone only to the default one. This is the one case. This is one case, this is one case, this is one case, this is one case. So instead of using this one, if I use the curly braces over here, for example, okay, instead of using this one, let's use the switch under the brackets, that is this one. Now there is the switch case, and after switch case there is one more output that is closed, that is this one. Now if I execute this code, enter the number, again there is an invalid day. That is, there are different cases that is available. If I use here as a char, well, this is a number, that is 0 1 2 3 4. There is a hash include void main int 7 I. Yes. Which one? This one 7. Okay, let's okay, just a minute. Which brackets? Int brackets, it is 7. This is okay. That is a 7. Then there is a I. This is clear screen. Enter the numbers. Everything is fine. No. But we have used over here 0. So if I change to the int, so it is not possible. You said I have changed to this one, right? But how is it possible? Let me try. The third day arrives correct. That is, the third day is Wednesday. But that does not mean that everything is correct. There is some error in this one. Switch one. So give me only one day. I will try it myself, and then I will tell you the code. Okay. So I will let you know the what is the problem in this in the tomorrow's class. All right. And in the tomorrow's class, I will be covering your next topic, that is the theoretical chapter or theoretical topic of this one. All right. So don't worry, don't take tension. I will be covering in the next chapter, in the next class, the same topic. All right. So thanks a lot. Bye bye. In the tomorrow session, covering the practical approach as well as the theory approach of the chapter number 19, that is interaction within the hardware or interaction with the hardware. So thanks a lot. Bye bye everyone.